Yeah, hello guys, you're welcome to my YouTube channel, Mathematics Made Easy. So in today's video, we're looking into some questions in abstract algebra, but number theory to be precise. So Chinese remainder theorem. So I want to solve this system of congruence equation using the Chinese remainder theorem. Now here's the question. The question says, now the question says that find the smallest positive integer of x in the below system of congruence. So you have x is congruence to 1 over 3, you have x is congruence to 4 over 5, you have x is congruence to 6 over 7. Then how are we going to solve this question? Okay, now let's start solving the question. So from this equation 1, from this first equation, so I can say let x be equal to 3k plus 1. Now, the meaning of x congruence to 1 over 3, it means if you multiply 3 by a number k, then if you add it to 1, it must give us x. That is, this x, this 3k plus 1 will be divided by 3, the remainder will be 1. So that's how we have x congruence to 1 over 3. So the question is, what will be the value of this x? They're going to get 1 over 3. That's the question that we want to solve. And then what will be x to get 4 over 5 and to get 6 over 7? And then we look at this equation is 3, 5, 7, they are co-primes, okay? Now, the GCD of 3 and 5 is 1, the GCD of 3 and 7 is 1, the GCD of 5 and 7 is also 1, okay? So the co-prime. Alright, so we said x equal 3k plus 1. So what we're going to do next? Don't forget k is set of integers. So k is an integer. So since k is an integer, I don't know, we have x equal 3k plus 1. So what we're going next is to substitute 3k plus 1 into the second equation here as x. So instead of writing x now, so what we're going to write is 3k plus 1. So we're going to have 3k plus 1 equal 4 mod 5. Now what we're going to do next is to subtract 1 from both sides. So because the congruents are equal to, they are similar, so we can do some operation that we do for equal to also for the congruence. So we will subtract 1 from both sides, so we're going to have 3k plus 1 minus 1 congruence to 4 minus 1 mod 5. Okay, so we're going to have 3k congruence to 3 mod 5. Then we can divide both sides by 3. But note, not all we can divide. Like, it depends on the GCD of this number here and this modular. But if you check 3 mod 5, 3 and 5. The GCD of 3 and 5, that is the greatest common divisor of 3 and 5 equals 1. So we can divide both sides by 3. Okay, so dividing both sides by 3, so 3 is going to cancel 3, so 3 is going to cancel 3 here. So you have k is congruence to 1 over 5. Good. So we have k is congruence to 1 over 5. Now, since k is congruence to 1 over 5, okay, now, don't forget, we said k is congruence to 1 mod 5. So we can rewrite k is congruence to 1 mod 5 in this form. Okay, so we can rewrite this as k equals 5 plus L plus 1. This remainder. So here L is also what? An integer. Okay, is a set of integers. That is, if you multiply 5 by something, then if you add 1 to it, so you're going to give us k. Alright. So what we're going to do next? What we are going to do next is to substitute k equals 5L plus 1 to be k in this particular equation here. So we're going to have x equals 3 into bracket 5L plus 1, then plus 1. Okay? So if you do that, we're going to have 15L plus 3 plus 1. So that will be equal to 15L plus 4. Okay, so we can now say x equals 15L plus 4. So then what we are going to do next is to substitute x to be 15L plus 4 and the third equation here. Alright. Then if we do that, we're going to have x is now 15L plus 4. So now 15L plus 4 is congruent to 6 mod 7. Then we can subtract 4 from both sides. So if we subtract 4 from both sides, we have 15L is congruent to 6 minus 4 mod 7. So 6 minus 4 will give us 2. So we have 15L is congruent to 2 mod 7. So we have 2 mod 7. Alright, now let's move on. Okay, now before I roll the ball, so now let's divide by 15, but take note of something. Now, 15 divided by 7, that's going to give us what? 2 remaining 1. So we can rewrite this as 1L is congruent to what? Is congruent to 2 mod 7. Okay? So 1L is congruent to 2 mod 7. How do you get 1L? I said 15 divided by 7. So that will be 2 remaining 1. So the remainder is 1. So we have 1L is congruent to 2 mod 7. Okay? So that's where we have. So we have 1L is congruent to 2 mod 7. 1L. So let's use red marker for that. L is congruent to 2 mod 7. So we can rewrite these. We can also write these as follows. So we can say L is equal to 7m plus 2. Okay, 7m plus 2. That is, if we multiply 7 by some integers m, okay, then if we have 2, we're gonna get L. Okay, we're gonna get L. Do you understand now? So what are we going to do next? Okay, now from this part we have x equal to 15L plus 4. So we substitute back the value of L into this part right here. So now we're gonna have x equals 15 into brackets now. L is now 7m plus 2. We have 7m plus 2, then plus 4. This one here. So we're gonna have x equals now 15 times 7. So 5 times 5, 7 times 5, that's 35. Keep 3, 7 times 1, that's 7, plus 3, that's 10. So we have 105m plus 15 times 2, that is 30, then a plus 4. So we have x equals 105m plus 34. Alright, so that's the general equation for x. But the question is that we should find the smallest positive integer value of x and a system of congruence equation. So what we're going to do is to substitute m to be 0. So we substitute m to be 0, we have x equals 105 into bracket 0 plus 34. So we have x equals 34. So that's the smallest positive integer value of x in the system of congruence equation. So guys, thanks for watching. Don't forget to subscribe to my channel, like my videos, share. See you next time. Bye.